Hi, everyone. I hope you guys are having a fantastic day, enjoying this day off. Um, so, we just took the test, right? We just took the test, and I haven't graded those yet, but I'll get to it. And our next chapter, actually, that we're going to focus on is nuclear reactions. Now, uh, and there's three different reactions that we're going to kind of focus on in this chapter: fusion, fission, and nuclear decay. And to start off, we're going to be talking about nuclear decay and what actually a half life is. Okay. Uh, so what I'm going to do is I'm actually going to show a half life PowerPoint right now. So I'm going to share my screen about half lives. Uh, and half lives is really exactly what it sounds like. Okay, it's half the life uh, for an object to decay. Okay, so what it looks like is here's the definition, and if you have to pause at any point in the video, please feel free to do so. Every radioisotope decays at a specific rate depending upon its half-life. A half-life is the time required for one half of the atom in an unstable isotope to emit radiation and decay. Okay, so it's the amount of time for one half the atom to decay. Okay, so 10 grams of material. After one half-life, it's going to turn into 5 grams of material. After another half-life, 2.5. Okay, so you're just taking halves. Okay, just taking halves. So if you look at this, nitrogen-13 has a half-life of 10 minutes. It undergoes radioactive decay and turns into carbon-13. How long will it take for 4 half-lives to pass? So what I'm actually going to do is, let me set up a one. Okay, and I want to have this screen going. So what ends up looking like perfect. So if one half-life, I always represent half-lives by an arrow. So if one half-life is 10 minutes, how long would it take for 4 of those to pass? Well, each one's 10 minutes. How long would it take? The answer would be 40 minutes. Another question. If you started with 2 grams of nitrogen-13, how much nitrogen would remain after 3 half-lives? Well, if you start with 2 and you have 3 half-lives, well, what's half of 2? Well, 1 half of 1 is 0.5. Half of 0.5 is 0.25. So that would be your answer. Now, the next question says, how many grams of carbon will exist? Well, this was nitrogen, and whatever decayed turned into carbon. Well, nitrogen went from 2 to 0.25. So how much did we lose? Well, 2 minus 0.25, we lost 1.75 grams because that turned into carbon. And that's some of the practice. Okay, I want you to try this one problem out. And if you need to pause the video, please do so. Okay, but I am going to describe it real quick. So nitrogen-12 has a half-life 2 minutes. If a sample started with 60 grams, so I'm going to write that out, sample started with 60 grams, how many grams would remain after 4 minutes? Okay, so I know one half-life is 2 minutes, another half-life is 2 minutes. So how much would remain? Oh, what's half of 60? 30, half of 30? 15 grams. Okay, so that's the first question. How many grams would have decayed into a new isotope? Well, if I started with 60, I finished with 15. That means 45 grams is a new isotope. And that's what half-lives look like. Okay? And one last thing is to view a chart. Okay? So if you start with 100% and you go down to 50, well, that's half of it. How long did that take to get down to 50? Well, you got to see what is the distance from here to here. Well, 0 to 30 years. Okay, so that's your answer, 30 years. Okay, and what percentage would remain after 100 years? Well, there's not really 100 years over here, but you can assume it's probably about right there. And if you go over, I'd say around 10. So 100 years, you go up, meet your line, see how long it took, about 10%. Okay, so that's the presentation, okay? Now, in Google Classroom, what I did was I posted a little assignment, and it looks like this, where you're going to need a piece of paper, okay? You need a piece of paper, and, oh, I already filled out some of the, wow, why is it all filled out? I might need to change that. Man, okay. And you're going to essentially cut it in half, okay? And see how much decayed. Rip another one in half. How much decayed? Rip another piece in half. See how much it decayed, okay? And analyze the final results, right? So if you guys have any questions, please let me know. I'll try to be around my computer a lot today, so just shoot me an email. If not, I hope you guys have a great weekend and look forward to seeing you on Monday.